Welcome back. I'm going to start talking about section 10.2, troubleshooting single area OSPF implementations. I'm going to have to do this in at least 2 videos, if not more. The first 1 or 2 videos will be OSPFv2, and then we'll talk about the same sorts of concepts for OSPFv3. Now, when we talk about OSPF troubleshooting, there are some basic things to keep in mind. It is a very popular routing protocol for large enterprise networks, and because it is an open protocol, it is popular for networks that don't strictly use Cisco hardware. And in point of fact, you may find OSPF running on a lot of large networks, even if they are only using Cisco's hardware, because it is so scalable, because of the way it initially converges and then recomputes when topologies change. There are a lot of things going for OSPF, particularly if you're willing to do your homework right off the bat. Sorry about that. As I said, if you're willing to do the legwork, the planning work ahead of time, so that you have a really logical IP subnetting plan, a hierarchical plan that you can subdivide as needed, that you can break into multiple areas to avail yourself of the strengths of OSPF without dealing with its weaknesses by doing multi-area OSPF. Now, this is a chapter on single area OSPF tuning and troubleshooting. Remember that the best way to build a multi-area OSPF is to build all the areas that comprise that multi-area OSPF well. Be able to troubleshoot them, be able to tune them, and then the whole domain will work better. So a lot of our troubleshooting problems come down to neighbor adjacency. But before you get that, understand, this is something you've no doubt heard me say before in class, and will certainly hear me say again because it will go on being true. Troubleshooting is one of your most important skills. Being able to troubleshoot routing, being able to troubleshoot at layer 2 for switching, at layer 3 with routing and addressing, troubleshooting at layer 4 with transport issues, troubleshooting in the application layer, that's 5 through 6. Absolutely do everything in your power to develop your skills in terms of troubleshooting. Don't leave any, even if it's not assigned, if there is a packet tracer in Netacad with the word troubleshooting in the title, do that. Work it. Work that packet tracer or that lab until you've found everything, until you've documented everything, until you figure out what was wrong and why it was wrong and how you fixed it. Just fixing it is great. Really understanding how you got to that, what you noticed that led you to believe that, hey, this is a misconfiguration, or that is missing. Say, for example, wait a minute, my routing table is wrong. My routing table is incomplete. I know for a fact that that network over there exists, but no one else is hearing about it. So why? Ask yourself the question, why can I not do what I expect to be able to do? Then backtrack. Is there a neighbor adjacency missing? Is the router there, neighbor adjacent, but not advertising the network, etc., etc., etc. So going back to neighbor adjacency, if the interfaces are not in the same layer 2 segment, no neighbor adjacency, obviously. If they are not in the same layer 3 subnet, you will also not get neighbor adjacency. You will also not get neighbor adjacency if you accidentally give the same address to both ends of the line, shall we say. If you create an address collision, that will also not work. If your network types don't match. Say, for example, if you're trying to build a neighbor adjacency between an Ethernet network, a multi-access network and a point-to-point, that's not going to work either. If your hello and your dead timers don't match, that is not going to work. If either the interfaces that should be part of that neighbor relationship are configured passive, they are not sending hello messages. Now they're listening for them, but they're not sending them. They really have to do both in order for neighbor adjacency to form. If the network hasn't been included in the routing process, so it's up, the routing process exists, the interface is correctly addressed, you may literally be able to ping back and forth across that line at layer 3. But if you don't include the network, either by issuing the right network statement in your OSPF router config mode for OSPFv2, or you don't add that network that OSPF area to the interface for OSPFv3, IPv6, it won't work. Now, missing, obviously, if the network statement is not there, obviously nothing's happening. The other thing that can go wrong here is if the network statement you provide in router configuration mode does not precisely match the mask of the interface configuration mode you use on the physical interface. Say, for example, you build a /24 192.168.137.0/24, and then in OSPF router mode, you declare 192.168.137.0, and then you do a mask, say an inverse mask of 0.0.0.0/.128. Say, for example, you accidentally declare it as a /25 instead of a /24. OSPF will look at that interface configuration, the network statement, it will see that they don't match, and it will do nothing. Also, if your authentication is misconfigured, and then finally, going down to, as I sort of touched on this already, but your layer 2 issues, if it's not up at layer 2, and if it's not correctly addressed at layer 3, nothing's happening. The next thing we need to think about is OSPF states. You have to understand the internals of the algorithm, how it establishes neighbor adjacency, how it moves from the down state to the two-way to xstart, how it synchronizes the OSPF database, how it converges, and what good looks like. You have two possibilities. When everything is up and going, every interface should be in either the full state or the two-way state. Any other state indicates that it is not fully converged and not fully conversing with the other systems. So understand exactly how it flows through this process. So every host starts in a down state. The routing protocol is not up. It's not sending hello packets, nothing. Then they initialize themselves. They turn on the routing process. They start sending hello packets. They start exchanging them. They go into a two-way state. Then once they have the neighbor adjacencies, they start exchanging information using LSAs and LSUs and things like that. They go into the exchange start state, the exchange state, loading state. In the loading state, they are moving. They are most of the way toward convergence, and then finally, boom, they all converge. Now, that being said, you would not expect to stay in any state except two-way or full for more than a few seconds. And you can actually watch this happen when you say, if you have a simulated OSPF network, say in a packet tracer, and you do clear IP OSPF process on all of them, you bring all the interfaces down, and what do? They break their neighbor adjacencies. Then they reform them, and you see them go into the down state, and then init load it up. If you really want to watch this happen, you can turn on your debug. Now, speaking of your troubleshooting commands, you can use these commands on the basis of what you think you need to learn. For the most basic information, do show IP protocols. That, honestly, if you think you've got OSPF running and you do show show IP protocols, and you don't see a routing protocol with OSPF and its process ID up at the top of that listing, you don't even have it running. The NSF thing at the top is nonstop forwarding. This is a layer 3 technology. Basically, the router is capable of routing, of basic layer 3 routing, but it doesn't have any routing protocols running. Then, of course, show IP OSPF neighbor. Very useful for establishing your neighbor adjacencies, for confirming them in point of fact. Show IP OSPF neighbor interface will show you everything that IP OSPF is doing with a specific interface. If you do show IP OSPF interface, it will give you all of them. Or you can specify one, or you can tell it show IP OSPF interface brief if you're working with real hardware. In Packet Tracer, that option doesn't work, unfortunately. Then show IP OSPF will show you the process ID, the router ID, other things like that. You can look at your OSPF routes in the routing table by specifying show IP route OSPF. You can also do this with static or RIP or EIGRP, or you can even do show IP route and then the destination network you want to reach. And you can have it tell you how it's going to route that packet, even if it doesn't have a packet to route. Then finally, you can clear the OSPF process with the clear command. If you do this, clear IP OSPF process all by itself, it will clear all of them simultaneously. If you do just clear IP OSPF and the name and then the process, it'll clear just that one. Now, in terms of our troubleshooting components, there's some things to think about. Step 1, ask yourself, is the neighbor table correct? If it is not, do show IP OSPF neighbor, or show IP OSPF interface brief, or show IP interface brief, or show IP OSPF interface, or even show IP OSPF interface brief. If the neighbor table is correct, but it's still not doing what you think it should be doing, is the routing table correct? Do show IP protocols. Do show IP route OSPF. On all the routers that might have something to do with not only on the router that doesn't have the route, but think about the other routers on the path between the router that should have the route and the router that should be advertising the route. Say, for example, you've got 3 routers. Like one of our topologies from Chapter 9, you've got the 3 routers, and they're kind of in a tree, with router 2 representing router 1 and router 3 to each other. If you don't see a route on router 1 coming from router 3, you could look at the router 1 will tell you there's a problem because the route's not there. You can look at router 3 and see, okay, is it advertising the route? That's a really good question to ask. The other good question to ask is, does router 2 know about the route from router 3? Because if router 2 knows about it, but router 1 doesn't, then you can focus your attention on why router 1 and router 2 are not talking to each other correctly. So is the routing table correct? Show IP protocols, show IP route OSPF. If the neighbor table is correct, and the routing table is correct, but the traffic does not seem to be taking the correct path. Say, for example, you trace route from point A to point B, and it goes through point C when it should have gone through point D, or something like that. You can ask yourself, why is this happening? What are the costs associated with these routes? And perhaps it is not taking the correct route because you don't have your auto cost reference bandwidth set correctly. If you're okay, just a second. So for neighbor table issues, for neighbor issues, one of the first questions you should ask yourself are these networks advertised to are these networks known to OSPF? The other question is, are the interfaces passive? If the answer to either of those questions is wrong, say it is passive when it shouldn't be, or it isn't advertised when it should be, fix that, and neighbor adjacency may resolve itself. Finally, routing table issues. Look at show run pipe section router OSPF. Look at your passive interfaces. Look at your networks. Look at whether those networks are correctly masked out. Like I said, if your interface has one mask and your network statement has a different inverse mask that doesn't correspond to that, it won't work. You can also look at, say, so in this case, for example, maybe that should have been a, hold on, stop that. Okay. Thanks. You can also look at this with show IP protocols.